I'm gonna go ahead and start. So this is deadlock detection. So there's two algorithms. There's Banker's algorithm and deadlock detection. Right. So those are the only two ones that you'll probably see tomorrow. I'll just start off by showing this one first. So I'm going to label these processes as P1, P2, P3, P4, and P5. This is P1 over here, P2, P3, and P4. Can you guys hear me, by the way?
Yeah,
Everything's good?
yeah.
All right. So these are all processes. Each one is individual to each one. I did this wrong. This P4, P5. And I'm going to move this V right here to the side. So this is the R. This is the formula to get the total amount of resources. To
You're
get the total
recording,
amount of
right?
resources, you're just going to add each row all of this with the V comparative. So
For the R, right?
yeah,
Wait, is the R formula always given to you? Or do you
he
have
might
to
write it. Probably not. I don't think he did it on the practice, but it's just A and V.
and then
So you're gonna add all of these numbers, then all of
wait,
these, all
I'm
of
just
those.
making sure. Are you recording this?
Yeah, yeah, yeah.
Okay, just making sure.
So I'm gonna
All right,
look at
go on.
the one. This is at 2, and then this is 3.
3,
This is 3. 1,
4.
2, 3, 4.
I mean 2.
1, 2, so 0. So you're just adding them all. That's it. This is gonna be your R. It's really easy. And yep. So that's R. So to actually get to the final W, you're going to take this V and compare it to every single one of the Qs. So I'll start off. They use a duplicate when compare it really like a W, but I don't think it's be a big deal. So I'll just start off with process 1 here. So P1, 1, 1, 0, and then I'm going to compare it to 1, 1, 0 from the V. I'm just saying it's W. Just that's where that come from. So as I see right here, for a deadlock to occur, the process has to be bigger in just a single one, because we're going to compare one at a time. So I'm going to go, okay, 1, 1, 1 is the same, so it's not bigger, so it's a safe. In just that case, then I'm going to go to another one, 1, 1. It's the same, so the left side isn't bigger. So this is still safe. Then I'm going to go to the next one. So these are the same, 0, 0. They're the same. So this whole process is safe. If, say this was actually, this process had a 1 here, and I would compare it here and here, then this process would break because you only need 1 to be bigger for it to cause a deadlock in the entire process. But right now we don't have that case, so don't worry about that.
So it's safe.
So 0 is right here. So this is a safe process. When you have a safe process, this comes from the Q, from right here. So we were at P1. So I'm gonna go look at P1 in the allocation over here in this matrix. So I'm gonna use this and add it to the V, the original V. So this is 0, 1, 0. So when I add all of these together, I'm gonna get, okay, this is 1, this is 2, and this is 0. So this is gonna be my new V. I'm gonna say W just because I think that's right, but it's basically the same as V. So just, this is what I'm gonna use to compare to the next process in the queue. Same as I started here. So I'm gonna go to P2, drop all that down here. So I'm gonna say 0, 1, 0 is P2 in my queue, this queue here. So also break that. So 0, 1. 1 is bigger, so that's still fine. 1, 2. 2 is bigger than 1, so that's okay, that we're still safe. 0, 0. So this is another safe process. And I'm going to have to go here to the A and P2 and take that just like I did over there. So 1, 0, 0, P2 from the A matrix. And I'm going to add it just like I did before. So 2, 2, 0 is my new W. And I'm not going to write W anymore. I'm just going to transition it. So I'm going to compare it to P3 and the Q. So this is 1, 0, 1, 1, 0, 1, P3. And I'm going to start comparing. So 1, 2, they're okay because 2 is bigger, so this is still safe. 0 and 2, 2 is bigger, so that's okay. But I see on the left side on the process, 1 is bigger than 0. Now that is where a deadlock occurs. So this is bigger, unfortunately. So this is a deadlock. So P3 is deadlock. So this is, you don't have to do this, but it's just to keep track because of how everything's gonna work. So this, it's basically gonna act as a queue. I'm gonna put my P3 in my queue. So this is my queue of processes that are deadlocked. P3. And then I'm gonna keep the same one and then go to process 4. 2, 2, 0. So my process 4 is 1, 1, 1. 1, 1, 1. And then I'm gonna compare again. 1, 2, that's okay. 1, 2, that's okay. 1, 0. It breaks here in this
Deadlock.
1. So this is what's causing another deadlock in P4. So I have a deadlock again.
Mm.
So I'm gonna put that P4 is deadlocked here in my queue.
Mm-hmm.
P4. Are you guys able to see everything?
Yeah.
Everything's so far played here.
Yep.
Okay. So same thing. Nothing's gonna happen because it's deadlocked. I'm just gonna move on to P5 to compare again. So P5, 2, 2, 0, and then my P5 is 1, 0, 0, 1, 0, 0. Make sure yep. So I'm gonna start comparing. 1, 2, that's safe. 0 and 2, that's still safe. 0 and 0. So this is a safe process. because everything is bigger or equal to on the left side. So this is safe. And when it's safe, I go to the A matrix of P5 here, and I'm going to add it. So 0, 1, 0. And let me just add. So this is going to be 2, 3, 0. And this is my new W. So we went through everything here. We already went through everything here, but we still have a Q that we have to go back because we did add something here and our Q, I mean our W changed this value. Now I'm gonna spoil it. They're probably not gonna make it safe, but we're still gonna go through it because that's just what we should do. So I'm gonna go to the first one in our queue, P3. So P3 is 1, 0, 1, 1, 0, 1. Now I'll just speed run this a little bit. So 1, 2, that's safe. 0, 3, that's safe. 1, 0, that causes a deadlock uh, right here. So that's still deadlocked.
Mm-hmm.
And I'm just going to move this over here to P3 at the end of my queue. And I'm going to go to P4. So P4, and this won't change. 2, 3, 0. P4 is 1, 1, 1, 1. 1, 1, 1. Let's compare it. 1, 1, 2, 1, 3, 1, 0. So here I get a deadlock. Again, same thing, same issues. It was the same ones, but that's okay because I know I'm going to go to my queue and move it back. But here, no matter how many times I keep doing this, I'm still going to get a deadlock in the same ones. So these are going to be my deadlocked processes. So he's probably going to ask you what processes are deadlocked. This would be your answer for that, P3 and P4.
Mm-hmm.
And this would be your final W, since this is W.
Yeah.
So 2, 3, 0 is your final W. So let me
And then
just
the
make
R,
sure.
and then R would be like
Yeah,
V
R is,
plus A, the entirety of it. Okay.
yeah, this is R.
Yeah.
Whenever we added that with the V. Yeah. Anything confusing or anything like that?
Oh, I got it.
Eric, you're good?
Yes.
Okay. I'm just gonna pause to make sure the recording to make sure everything's good. I'm pausing. Okay, so this is the same problem as the last one that we were just
Mm-hmm.
doing. The only difference is this is all the same. This is different, but only in process 3. So I know we got deadlocked in process 3. So what I wanted to do to show was make process 3 all zeros. So what this will do is I'll show it. I'll show it. I'll go through finding R. So I'm gonna do my V from here. So 1, 1, 0. Then I'm just gonna add everything from all the rows. This. So this is 2. Oh, shoot. This is 2. This is all right, blue.
5.
5. Was it 5 last time?
No, it was 4.
Yeah, you're right. Oh, sorry. This is
1.
so it's supposed to be 1, 0. So this is actually 3. This is 4, and this is 1. So this is different because I put a 0 here instead. So this is how I want it to be, just to for the sake of showing you what a process that has all zeros will do. Yeah, so this is going to be your R in this case. So R, and then V, we're going to start comparing just like we were before. So I'm going to compare process 1 with V. So I'm going to start that. So my V is 1, 0, so there. And my other one is 1, 0, P1 from the Q, from that one. And I'm just going to compare. So same, 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 same. Everything's here the same. So it is safe. Let me just do safe. And then I'm going to do P2. So P2. P2 is 0, 1, 0. Then this, oh, I'm so sorry. I'm supposed to add after it's safe. So I gotta add P1 from the A to 0, 1, 0. So this is going to be 1, 2, 0. So this is going to be my new V/W. So this is what I'm going to use when comparing, just like before. Let me write process 2 now to compare it. So 0, 1, 0, 1, 0. This is P2. Let's compare. So 0, 1, 1, 2. Everything's safe so far. This is safe. Yeah, so this is still all a safe process, just like in the last one. So this is safe. I'm going to add the allocation here, will be here. So this is 1, 0, 0. Let's add. This will be 2, 2, 0. And I'm going to compare it to P3. So P3 is 1, 0, 1. Right here. 1, 0, 1. P3. So let's compare 1, 0. Oh, sorry. Let me start with it. So 1, 2. That's safe. 0, 2. That's safe. Now here, this causes a deadlock. But there's something freaky going on. We got P3. So you have to look at the allocation. If you have any in this allocation one, not in this one, not in the Q one, in the A one, that all have the whole process is just zeros, it's going to be a safe one regardless. So that's going to, instead of originally causing a deadlock, that's going to make it safe. And the reason is a deadlock will occur because we're sending resources to the process. But if we have 0 resources to send anyway, there's no problem here, because we don't have, when we have a deadlock, say we have a deadlock and I'm sending resources to a process that's like, just say the number 3. I'm sending 3 to fix this deadlock. I'm going to have to send 3 back and like shut it off, basically, something like this. But because I have 0 originally, I can't just send back 0 because there's no point. There's no issue here. So that's why this is a safe process. Do you guys have any question about that part? about why P3 is safe?
No.
You're good? Okay, that sounded very confident. So yeah, it's safe. I mean, I don't have to add it because it's all zeros anyway. So I'm just gonna move on to P4 and Q. So P4, 1, 1, oh, 1, P4, 2, 2, 0. So 1, 2, safe, 1, 2, safe, 1, 0. This breaks because of this one, these two. It's bigger on this side, so this is a deadlock. Deadlock. And I'm gonna put my P4 in my deadlock queue. So this is P4. And then I'm gonna do P5. So my P5 is 1, 0, 0, 1, 0, 0. And yeah, 2, 2, 0. I'm just gonna compare again. 1, 2. And 2, that's safe. 0, 2, safe. 0, 0, safe. We're good. So this is safe. Then, after finishing all of these processes, I'm going to check P4. I know it's not going to change, but it's still good practice. P4 is 1, 1, 1. 1, 1, 1. 2, 2. You see that? So you're going to check again. 1, 2, 1, 2. It breaks here again. And this is still a deadlock. So this would be your only deadlock in this process. And this is your final W as well. 2, 2, 0. Did I do something wrong? I'm so sorry. I forgot to add P5.
P5 safe, yeah.
Yeah.
Nah, bro, messing up.
Should edit that out.
Wait, what about P3?
P3 is
Did
0,
you add?
0.
Oh,
Yeah, so it's
okay.
not gonna change
Yeah.
anything.
Oh, yeah, I was like, okay, yeah.
So I just gotta add 0, 0, 1. 0, 1, 0. So this is 3, 2, 0. And then just P4. You check P4 because it was in your queue. Just real quick. 1, 1, 1. 1, 1, 1. So this is how it should be done. 1, 2, 1, 3, 1, 0. That's where it breaks. Deadlock. And boom, now this is your actual W. 2, 3, 0. Deadlock. Your only deadlock is P4. And this is everything that you'll pretty much need for deadlock detection. I'm gonna do bankers right after this. Okay, so this is Banker's algorithm. So this is everything that they're going to give you. They're going to give you the C, which is this matrix here. They're going to give you A, which we're familiar with, as it's the same as in the detection one. This is the same A as this one. And we're going to use it the same later on. So they also give us R. So we're kind of working a little backwards here because we have to find V. And we also have to find this matrix that is given to you from C minus A, which I'll talk about later. So let me find V first. So in the last one, we were doing R is equal to V plus A. And let me just erase this so that I can, so R is equal to V plus A. If we're given R, I want to find V, so I'm just gonna move minus A to the other side, so R minus A is equal to V. So that's exactly what I'm gonna do. I'm gonna subtract R minus A to find V. So I'm gonna move this up top. So it's actually, let me collect all of these first so that we have some numbers to work with. So I'm going to do that. So all of this row is 3, this row is 4. So I'm just adding them all right now. So this is 4. And let me just make sure I'm recording. Yeah. So this is 4. This is 4 also. And this is what I'm going to subtract with my R. So I'm gonna actually just move this below just so it's more easier to see. I can just write it. So this comes from my A. So this is A. And let's just subtract. So my V is 0 here. Minus 6 minus 4 is 2. 5 minus 4 is 1. 7 minus 4 is 3. And this is my V. So now I have my V. And if it says in the question, what's your initial V? This is what you're going to write. And now I want to find my C minus A. Except in this case, I want to do it as a matrix form. So I'm going to pause. Okay, let's subtract each one. So I have to go one by one. So you have to be careful in this. So 1, 1. This is 0. So you're subtracting 1 minus 1. I'll go coming this way. 1, 1 is 1. So 1 minus 1 is 0. 1 minus 0 is 1. 2, 1 minus 2 is just 1. 3 minus 1 is 2. 3 minus 0, 3, 2, this 1 is 1. 3 minus 0 is 3. 3 minus 3, 0. 4 minus 1 is 3. 1 minus 1, 0. Shoot. 2 minus 1. You could also use Excel, probably be quicker. But yeah, I'm just gonna do it by hand to make sure. 1 minus 2 minus 2, 2 minus 2, so they're both 0.
So that would be Q, right? Or
Yeah.
C minus A.
So this is C minus A, which is going to act the same as our last Q, but just for naming sake, C minus A is fine, I'm sure. So I'm going
Oh
to
yeah, it
just,
makes sense now. I get it now. Sorry.
you get it?
Yeah, you can name it Q. Yeah, that's fine.
I mean, I'm just gonna do it like that, just in case. Yeah. So I'm just going to put it in that place, and then start working off of it with my V here. And I'm also going to bring down the A so that we can work on it just like we were before. That was somewhere else. Okay, so I'm going to bring down my V so that I can use it. So here we're actually just going to manipulate the V itself. So it's always going to be V. So 2, 3. And then this is where I'm going to start with my processes. P1, P2, P3, P4, P1, P2, P3, P4. So let me start with the process of this one, C minus A, and V from Q. So let me compare 0, 1, 0, 1. This is
Uh-oh. Charge your iPad, bro.
yeah, P1. Let's just compare now. 0, 0, safe. 1. Oh, this is also the same comparison as in the last problems, where if the process is bigger, it's just going to cause a deadlock. If our V is greater than the process or equal to, then it's safe. So we're just going to follow the same rules as before. So 1, 2, this is safe because 2 is bigger. 1 and 0, 0 is less than 1, so that's okay. 1 and 3, 3 is bigger, so that's a safe process. So this is safe. And we're still going to do the same thing here. So I'm going to go to process 1 of A and add it onto my V, because this is my V. So 1, 0, 1, 0. And I'm just going to add all of this. 1, 2, 2, 3. So this is my new V. And I'm going to move on and compare it to P2 over here. So 1, 2, 3. Let me do 1, 2, 3, 1. Yeah. Is P2. So I have 1, 1. Comparing, that's safe. 2, 2 is safe. 2, 3. Now this causes a deadlock. I have the deadlock here. 2 and 3. Which is a big problem. So this is just going to be deadlocked immediately. Unless for some reason there's 0, 0 in allocation, but obviously there's not. This is a deadlock. I'm going to make a little Q up here. Let me just do it right here. Q. And I'm going to put P2 in my Q. Just put P2 right there. And then I'm going to move on to P3. 3, 30, 30. So P3, 30, 30. And I'm going to move this down here. 1, 2, 2, 3. I'll write that just for the last one. And then I'm going to compare. 3, 1. That's already a deadlock. So I'm just going to write deadlock. And then I'm going to put my P3 process and then the deadlock queue. P3. And then I'm going to move on to P4. P4 is 1, 0. Wait, sorry. That's from the 8. So 1, 1, 0, 0. 1, 1, 0, 0. And then I have 1, 2, 2, 3. And then I'm going to compare. So use the other one. 1, 1, safe. 1, 2, safe. 0, 0, 2, 3. Yeah, that's gonna be safe. So safe. So my P4 is safe. So let me go to the allocation of P4 and add this one. So 10, 22, 10, 22, and let's add 2, this is 2, this is 4, this is 5. Yeah. So this is my new V, and I'm just gonna move this down here because I'm gonna use it again. And I'm gonna go back to my Q right here, and I see that P2 is first. So I'm gonna go back to P2 and check if maybe I can unlock it now. So P2 is 1, 2, 3, 1. 1, 2, 3, 1. P2.
Mm-hmm.
And let's compare.
Safe.
1, yep, you're right. 2, 2, yeah, everything is safe. So this is a
Now we
safe
add the
process.
P2. Let's go.
Yeah, let's add
Calculation.
11 and 0,
1,
1
1,
from the
0,
A of
1.
P2.
Yep.
11, 0, 1. Plus 3, 3, 4, 6. This is the new V. And then let's go to our, oh, let's take off this from our Q, the P2,
Yep. So
now that
now
it's safe.
it's P3.
P3. P3 is 30, 30,
3, 0, 3, 0.
30, 30.
Yep. And we add that shit, and it's safe.
And yeah, let's compare it. So 3, 3 is safe. 0, 3, that's safe. 3, 4, that's safe. Yep, you're right, that's safe. Oh, let me write this too. The Rincon knows for the work. So this is a safe process also. We can take that off from our P3 and we see there's nothing else. So after this, we're done. Everything is going to be safe. And I still have to add the P3 from the allocation. So 0, 3, and 1, 1. 0, 3, 1, 1.
1, 1.
Is that it?
3,
3, 6,
6,
5,
5,
7.
7. Yes, sir. Yes, sir.
And this is our final V. And this is what you'll put as your final. 3, 6, 5, 7. And this should, because everything is safe, there's no deadlock, it should be the same as our R. So let me bring this down and see if it's the same. So if you have no deadlocks, this should be the same as your R. And yep, it's the same. So we most likely did it right. So yeah, this is everything. If you see 0 zeros, use the same thing I used. For if you see 0 zeros in the A and the bankers, just do the same thing for this one as I did in the other example, the second one. But just in bankers, whenever you have your
If there's
C minus.
if there's triple zeros, you just add the zeros, right? Wait, I mean, what's the
What do you mean?
difference if there's triple zeros or just like all zeros for A?
What I'm talking about here?
Yeah.
Yeah, I mean, technically, when you, yeah, but you don't have to, because it's safe because of it.
Yeah.
But if you want to, for sure, work.
Yeah.
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 Yeah, that's honestly it. This will be your final V. This is your initial V. Where is it?
Right there.
Right here. And this is your C minus A. I don't think he'll ask you for C minus A. Oh, also, there is one question. It's a yes and no question, I believe. It'll say that, is this state safe? Is this state safe? So this
Yes.
is just this is a yes or no. Yes, no. So it's going to be yes if you have no deadlocks. Just absolutely no deadlocks. In this case, we have no deadlocks. So this is yes. If we just have one deadlock, the P3 was still a deadlock, then this would be, you would put no, that it's not a safe state. So yeah, that's how you do pretty much everything. So you should be good. And yeah.